Hi, hello, how are you? Welcome back to my online tutorials. We are continuing our Docker series. In this video, we are going to see how to generate huge data. So, since we are using Mongo, so we generate the data in the format of Mongo, which is based on documents. But we will see how to generate huge data in this video. So, this video contains a lot of information if you are trying to use or if you're trying to learn data science or if you're trying to generate applications on huge data huge data based applications, this video is the best place to start with. So let's watch it till end and let me know if you have any questions. So as I mentioned earlier, all my videos will have real-time scenarios, hands-on experience, and lots of interview questions, step by step demos, and each and every minute details. So let's watch. So, first of all, why we have to generate huge data? So, if you are working on applications uh, and if you want to see real time scenarios where uh, applications deal with huge data, you have to generate some huge data. So, if you can generate maybe 10 records or 20 records, but I'm talking in terms of millions of records. So in that case, you have to generate some sort of data which is not real. That means the identities, names, uh, and identities will not be real, but the pattern will be same. That means the record, if you see in the real time, and the generated by this application will be similar. It will contain the same format, but the identities will be different. So coming back to why we need to generate huge data. If you want to learn the real-time scenarios like the aggregation pipeline, and if you want to really do some performance testing, you have to generate the data which will similar to real-time data. So that's why um, in this video, I'm going to show how we can use a framework called Bogus, which is a NuGet package by .NET. So this will help you to generate huge amount of data and with real-time format. So in this video, I'm going to generate chess players information. As I mentioned, the identities will not be real. But if you take a single record for a chess player, it will reflect the real time data. That means the format of the data, the rules of the data will be real time, but the identities will be uh, not real. So in this video, I'm going to generate a chess player information and I'm using faker object. I don't like the name bogus and faker, but they named it as like this. So I'm going to use a faker object to generate the code. And also we will see how to apply the levels, rules, etc. And in this video, I'm going to use the namespace called bogus. So if you're already working with some testing frameworks, then you might familiar with what is faker and bogus. But a little bit about bogus and faker. So bogus is a popular open source .NET library which we can use to generate high quality, realistic fake data. So for testing and development purpose, it is a C sharp port of famous like faker.js library. So the bogus is a NuGet package you have to install if you want to use the faker, and it's a popular uh, library, open source library, where you can use it for generating the sample data. So the faker is a class in the Bogus library. So it's a powerful tool to use to generate realistic randomized dummy data for .NET applications. Like you can use it in C Sharp, F Sharp, and maybe .NET. It acts as a set of instructions or rules that tells the library how to create and populate mock data. So it's better to use the mock instead of faker and bogus mock objects for unit testing and performance testing or UI prototyping. So as I mentioned earlier, if you are already working using unit test cases or any integration test cases, you might be familiar with like faker and bogus objects. So let's see more on this video. So where we can use this bogus or faker. So if you are trying to generate sample data in lower environments, in production we cannot use them. But if you are trying to generate data for development and lower environments, you can use these namespaces. And test cases, if you are writing test cases where you need sample data, then there also you can use it. If you are doing some performance testing, then definitely you need some huge data. So these bogus and faker, they will be uh, best used when you are generating huge data. I'll show how to do that and test various use cases. So in this video, I'm going to use a console, a .NET console application, and this bogus and faker, and I'll show how to generate random data in a huge value. I created a console application and named it as chess players samples. So this is the namespace and the class, the program.cs. We are going to write the code here. But first we need to install few NuGet packages for this sample, for this console application. So let's do that. So if you want to install NuGet packages, click on Tools, NuGet Package Manager and Package Manager Console. So just bring this up. So we are going to use the Bogus. So install package Bogus. So this is going to install the Bogus. You can see in the packages, the Bogus 35.6.5 have been added after running this command successfully. I also want to install MongoDB BSON. Install package MongoDB dot BSON because I want to use the BSON format. Yeah, it's been successfully installed and you can see MongoDB BSON 3.9.0. So let's add program file. So class program, yeah, this will generate and you can make this public and this public static void main argues. You can generate public static void main args. Yeah, so later you can add the code here. Now let's add one more class, name it as chess player generator. So instead of line by line writing, I already have that class. So I'll paste it here, but we will discuss that class line by line. Okay, I added the class called chess player generator. So let's walk through that class. So first I created a faker object. So private read only the type of the faker is faker, and here I'm initializing that class. So then I have a set of private read-only properties. So these uh, private read-only all are string arrays. So these uh, will be used by your faker or the chess player generator to randomize few uh, few real like information. So let's see what is that. So the titles, if you see titles, the titles will be like few titles, the Grandmaster, International Master, FIDE Master, and Candidate Master. Like these are, you can think about the titles for each tournament. These are the few titles. There are many, but these are the few titles I want to randomize uh, while generating the data. So this uh, particular property will contains the different types of titles. So if you want more titles, you can add it here, but I added 4. So that means all the data, if you're generating millions of data, you will have only these 4 titles. If you want more titles, you can add it here, and your chess player generator class will use them and randomize uh, the profiles. So for those titles, these are the short codes and white openings. Again, like these are the very like few popular white openings. If you want, you can add more. So in a similar way, black openings. So these are the Sicilian defense, which is my favorite, and French defense, uh, Caro-Can. So these are the black openings. So similarly, I gave 1, 2, 3, 4, 5, 6 white openings. So I'm using 6 black openings. And these are the tags: elite, like professional, rapid, specialist, bridge expert, junior, veteran. So these are the tags I'm going to use. So then this is the method, generate players count. So if you want to generate 10, you have to pass the 10, and this method will loop through 10 times, and it will call the method, and it will generate list of BSON documents. So this BSON document is a uh, uh, document type. We use it in Mongo. So what is this BSON document basically? So BSON document is nothing but binary JSON. So it's a binary encoded serialization of JSON-like data. So um, especially when you are dealing with Mongo, the data which stored in the MongoDB will be in the BSON documents. So that's why I'm using this BSON BSON document type. So if you see here, this has been in the Mongo library, Mongo JSON library. So this method is going to generate BSON documents, a list of BSON document, and it is taking parameter like how many players you want to generate, and it will loop through those many times, and it will generate the players and add it to this players list. So let's go through this method. So the index will be the like if you are passing 10, it starts from 1 to 10, and each time this will contain the iterator here. So first the gender, again, the faker dot pick random. So the gender will be picked up this by this faker, and the values will be either male or to female. So every time it will pick a random uh, gender and the first name. So it's going to generate the first name again. The name will be based on the gender we choose. If we choose male, so the bogus dot datasets dot name dot gender, it's going to pick the name a male name. If it is a female, it's going to pick female name. If you want to generate a name randomly based on the gender it's choose, you can use this section for generating the random name. So from there, it's going to determine like what is the last name, first name, and full name. Okay. Then county. So the faker.address.county, again, it generates a random county name for the nationality location. Um, the classical generating rating. So there is another method. Uh, Go to that method, generate rating. So this method is responsible for generating the random rating for the profile we are constructing at this moment. So this will have again a bucket, a var, and it will take from 1 to 100. It will pick a random integer, and based on the number it pick, it will generate this rating. So if it is less than 5, then it's going to generate this. If the number is between this, then it's going to generate again a random number between these two numbers. So if the bucket is, then it will be this one. So if it is 70, then between 35 and 70, then it's going to generate a random rating for this. So this random generate rating is again the logic will be first it will pick a bucket. So based on the chosen number, it generates the rating for the particular profile. So finally, this will contain the rating. So then rapid, if uh, the based on the rating, so it's going to generate a rapid number and blitz number. If you are familiar with um, chess, these are the different ratings for rapid. They will have a different rating for rapid, and they'll have a different rating for blitz. So here the wins and loses. So again, for a particular uh, profile or player, it's going to generate wins and loses, a random wins and loses. So the wins will be between 105,000 and loses will be 50 to 2,000 and draws. So these are the three categories: wins, lose, and draws. And total games. So based on the wins, losses, and draws, it's going to get the total number of games. So the win percentage again. So the data we are generating will be random, but the few data points will be random. So the number of losses, wins, draws will be random, but the win percentage is like accurate. So based on the randomly generated data, we are calculating some of the data accurately. Like the win percentage will be, so based on some formula like wins total games 100 into 100, and then uh, it's going to calculate by this formula wins by total games into 100, and it's going to round up by 2 decimals. So once we have all these properties or all these data items, then we are going to write the BSON document, or we are going to generate the player BSON document. So ID, again, we are going to generate a new random ID, and the player ID will be like it's prefixing with player and some random number and the index. So based on the index we are providing in the parameter, then this is the personal info. Personal info. This BSON document again contains another BSON document. So the first name will be the name in the variable. The middle name, we don't have any middle name. So the last name will be the last name, and the full name will be the full name from this property. And the gender already it's been decided in the um, above lines by this variable, and then date of birth. So here I'm generating date of birth based on some random years. So add minus 60 and add minus 10. So based on this, it's going to generate a random data. So everything will be random here. You will not see the same date of birth for multiple. You might see, but um, it will be random. So it's going to generate a random date of birth. And nationality, again here, it's going to get the country code. Based on the country code, it's going to get the country. So again, it's going to generate country code, ISO like, and use previously generated country name. It's going to generate the country name. So go and see where we have this country name. Yeah, here we have the country name. So based on that, it's going to generate the country code. Then current location. So based on the address generated, it's going to get a city. Again, it's a random city um, in that particular location, and random state in that particular region, and reuse the previously generated. So once you generate the country randomly, these things will be uh, aligning with the country we generated. And languages, so here I'm hard coding English, and then professional info. So professional info, like this is the BSON array, and again we have multiple BSON documents. So title will be the titles. So this is going to pick a random title, but the random titles has some limit. So it will pick random title from these titles. So it will pick the short code for the selected title and awarded date. So again, it's going to generate some past 15 years awarded date. So it's going to generate a date for the fast from the date now to back to 15 years. So here we are going to replace numbers, generate a random field ID like FIDE ID. So by 15, and these 6 digits will be replaced randomly. So current rating, we calculated ratings for the different classical, rapid, and blitz. So those numbers we are using here. Then peak ratings. So the rating classical, so again, it's going to generate a classical random number, and achieved for the past 10 years. It can pick any date. And rapid, so this is the random number for rapid, and this is the date for the past 10 years, and this is for the blitz. So active status, again, it's going to choose either active or inactive. Then preferred openings for this particular player. So it's going to select any of the white openings. We listed 6 white openings, and it will pick a few white openings. So it picks 2 random white openings from this list. So again, it's a BSON array, and it will pick 2 black openings for that particular user or player. So also we are going to define the ranking. So worldwide rank based on the index, and country rank, it's going to generate the random number 1 to 300. Then coming to statistics, total number of games, number of wins we already calculated, and win percentage, yes, and game by format. So there are different types of formats. So how many games, the classical games, it's going to generate 100 to 2000, rapid 100 to 2000, and blitz also 100 to 2000. Here online profiles, so chess.com, like what is the, it's going to generate a random username based on the first name and last name. So faker.internet username. This method is going to generate a username based on the first name and last name given. And this one is going to define the rating on the chess.com. So similarly on leeches also it generates a username and also rating for that uh, leeches.com. So then metadata, like uh, like what is the source systems FIDE chess.com, uh, and these are the um, uh, source systems for this particular user. And tags, it's going to generate a pick two tags from the list uh, we defined. So it's going to pick two tags for this particular pair. And version one, metadata version number one, and is deleted false. So this is for Mongo uh, version management, and created by system. It's generated. We are creating it, and this created on will be today's date, and updated on will be today's date, because we are going to store this data in the MongoDB. So this is a entire um, BSON document. So then let's see how to call that chess generator and see how it's going to uh, generate different players. So here I'm creating object of chess generator class, and I'm calling generate players 2. So just I want to show how it looks like. Then we will do the same run by using 1000. But so here it's going to generate two players information, and that players information will come in a list format. And so here I'm going to convert that into BSON array to JSON, 2.json, JSON writing setting. So indent equal to true, output mode equal to relaxed extended JSON. So use relaxed extended. So here, so this line of code, what it's trying to do. So create BSON array from the players list, then convert JSON with settings. So this list, it's going to convert into a JSON and enable uh, indentation for human readable format, because the I'm going to write this information into a file. So that's why you have to enable indentation so that you can read it properly. And output mode will be relaxed extended JSON. So what is that? Use relaxed extended JSON to preserve types like object ID and datetime. So if you don't use this, then it will be strict format, which I don't want. So the list of information, we are going to convert this into this JSON format. And then here I'm going to define the file name will be chessplayers.json, and this method is going to write this information, the JSON information, into this output file. And here just convert that into two chess players documents generated successfully, and we can see the file. I'll open the file and I'll show the file. So let's run this code. So it's building, and then so first time it's going to take little more time. Okay, so just let it go so that we can see. Okay, two chess player documents generated successfully. Output file is the chessplayers.json. So stop running this and see the file. So stop running this, and where can we find the file? I did not give any path. So go to the program, the file, it's located, the physical location, and go to the bin and go to debug.NET 9, and you can see the chess player. So let's open this in the, okay. So here you can see the JSON, the file complete. Manu, is it raining, Nana? Okay, okay. Nothing. So this is the generated file, and you can see two players have been added. So ID, the player ID, personal info. So go to the personal info. This is the name, a random name, date of birth, and go to the second player, Gerald, Chris, male. Okay, then professional info, like the field ID, titles, um, international master, and for this FIDE master. So titles FIDE master. Yeah, so if you see, it generated two profiles, two players. So you can close this and rerun the program for 1,000 players. So I updated the number 1,000 here. So let's run this code one more time and see whether it's generated properly or not. So here you can see 1,000 test player documents generated successfully, and output file name is same. So go to that file and see. Yeah, now it's generated more than two. I can see here, see ID. Um, yeah, it's more than, yeah, this is a file format. So if I write the same into MongoDB, we can easily see that. So let's add some more code to your console application so that it will generate a file here, and it also add this data, 1,000 records, 1,000 BSON documents to uh, your MongoDB, the local MongoDB. Let's do that. So first I installed the MongoDB driver because I need a MongoDB packages, and then I added this code. So still some exceptions, you can resolve them. Yeah, using MongoDB. Yes. So this code is going to write information into your MongoDB collection. So this is the MongoDB local MongoDB. I think in my previous videos I have shown how to um, in detail how to establish connection from your MongoDB to your .NET application. You can go through that. So, but here it's a MongoDB connection, and this is the database name. I'll change it to today's date, 5 29 2026. So Mongo collection name will be chess players latest, because I already have those in my system. So just I want to distinguish. And then once then this client settings will be generating the connection. Then after that, this client is going to establish connection between your MongoDB, local MongoDB, and this application. And this is the database, and this is the collection name. I'm not creating the uh, collection. If there is no collection, it's going to create the collection. And this particular insert many asynchronously is going to write multiple BSON documents at once. So all the 1,000 documents will be inserted into your MongoDB. So let's run this code and see. So let's connect to your MongoDB by using Studio 3T because I want to validate the data. So I already have, but make sure your Docker is running if you are running this instance in the Docker. So now run your application and see it's going to create a new database. First, it's going to find this database and it will not find. Then it will create, if it doesn't find, it will create the one. And then it's going to find this collection. If it's not finding, then it's going to create the collection and then it will insert the data. So let's run this application and see. So I ran this application successfully and you can see 100 chess players document generated successfully and inserted 1000 documents into MongoDB collection. Uh, and this is the database name. So just refresh um, your Studio 3T. Yeah, I'm going to refresh my Studio 3T, refresh all, and you can see the chess hub with today's date and chess players latest. Open this and yeah, you can see run the data at a time. You can see only max 200, uh, but these are the BSON documents generated by your console application in a 1000 volume. So you have BSON documents of 1000, which has been generated by your console application. And you can see it properly. So it has ID field, player ID, and personal info, and nationality, current location, the languages, and professional info. And within that, titles, within that, current ratings, peak ratings, preferred openings, the white openings and black openings, rankings, statistics, online profiles, rating, leeches, metadata, the source system, tags. So whatever we have seen, it generated 1000 documents and the application dumped into your MongoDB. I hope in this application, I discussed a lot of important information and useful information like how to generate huge amount of data. Um, but this is domain related. If you know, I have some knowledge on chess. So that's why I was able to define all these parameters and I was able to generate this class. But what if you don't know the domain? So in my next video, I will take some of the automation steps, even though if you don't know the uh, domain, if you don't have domain information, uh, how to take, how to write a logic, especially defining this class is very important because this is going to generate uh, the random data. And if you define this class properly, you can generate any kind of data. So in my next video, I'll show how to automize this. Like if you don't have sufficient knowledge on a particular domain, but still how you generate, how you write this code proficiently or um, effectively. So for that video, I'll show how to take help of either Copilot or ChatGPT uh, for generating this kind of code. So I hope you like this video. Please let me know if you have any feedback and also let me know if you want to see any specific type of logic or if you want to see any type of any specific topic or to learn. You can text me in the comment section. So I'll make out some time and I'll prepare the videos. Thank you so much for watching my video once again. Please like, subscribe, and share this video for the useful people. And happy coding.